Okay, so next up, we have been referred to as the search team. I think of it more as the visual browser team. And so I'm going to introduce, I will introduce both Drake, pardon me, Zabriskie and David Wong. So Drake is the Chief Technology Officer for Luna Imaging. He's been with Luna Imaging since the start. So as we heard from David Rumsey earlier, that's going on almost 30 years, not quite, but it's been a long time. Drake was instrumental in taking Luna from CD-ROM to online, right? So there's a huge leap there. And I think he mentioned to me that he studied at Art Center, College of Design, and I think that this design sensibility is what's informed part of what you're going to see here. This kind of visual browser for machines reading maps data through Luna from the Rumsey collection. And David Wong is the software developer at Luna. He's been working at Luna since about 2006. He tells me he has a passion for coding and really enjoys transforming abstract ideas and concepts into tangible realities. For this work, Drake sort of emanates excitement about the whole darn thing. But he's particularly excited about the work that David has done to transform the single word annotations, right, which come out of the pipeline into actual, sort of understandable multi-word names, right? That's essential for search. For those of us who are in libraries or working with large data, we know how critical that part is. And also seeing his actual design of this interface as the mock-ups come to life. And David has told me that he's really excited about this opportunity to work with a massive amount of data, 89 million annotations. And then David Rumsey told me this is going to be up to 100 million in version 3. So welcome, Drake, and then David.
So I just wanted to say thank you to the whole team. This has been an honor to work with it, and David Rumsey and Katie just integrating it and making this happen. This has kind of been one of those things in the back of your head for a long time, and it would be a really wonderful thing to implement. And the whole machine reading map team, I have to give you guys so much credit for delivering and actually making something so useful, because you see data all the time, and it's really an honor to actually see that. So what do we do? Just do paging here? Okay, so anyway, we're just really talking about what we're calling as search and what actually is behind this, and giving you a bit of a understanding of what we're trying to deliver within the Luna application. So let me just kind of go into the backend annotation data as it actually can be delivered through web annotation, web annotation data. And you can actually pull this from Luna through it's not triple F. That's not triple F call, but it's a web annotation call, correct? Okay, and so what we have here is just to kind of give an example. I can find where the mouse is. There it goes. Okay. And we used Valeria's example, Toronto, and so if I said that right. But when we did a search, we did a single word search, and we're just kind of representing that, and it found 765 results. And this is just the first result of that particular item. And where we store a number of things. One thing, there's an ID that represents that particular annotation that it came from us, came through the map data. And then we have an internal ID that has to do with the map itself within Luna and the collection. And then it starts getting into some other information I'll let David kind of speak about.
Yeah, we've seen image coordinates and geo coordinates in the map creator pipeline. And the first batch is this is where these end up. The first batch of numbers are geo coordinates, and the second batch are image coordinates. We're not currently using the geo coordinates yet, but it will be in the future. The image coordinates are being used for spatial search within a multi-word search. And we're indexing OCR text from output from the map creator, and the post OCR correction text are also indexed. That these are the output from the map creator. And there are a few fields that we're indexing for enabling low case insensitive search and faceted search. Next, I want to talk about the difference between a single word and a multi-word search. In a multi-word search, it returns a match only when all terms are in close proximity, and which means they are within distance of 2 characters. And we do this by using the spatial search feature in Solr. I like using this example, this place called South Ponte Vedra Beach in Florida as an example, because this combination only has 1 match out of 56,000 maps. To start this process, first find the maps that contains all 4 words, and there are 12 of them. And then it counts the number of occurrences of each term by using faceted search. And in this example shown above, there are 54 occurrences of the word beach, and there's only 1 occurrence of the word Ponte. We want to minimize the number of times we have to run the following sub-process, so we choose to run this on the least frequent word, which is the Ponte polygon. And to begin, we first on the Ponte polygon, we want to find the average length of characters. And we do this by finding the 2 points that are farthest apart in this polygon. And then we divide this width by the number of characters. And with that number, we can run a Solr spatial search on first the left end of the Ponte polygon, and it matches the word south. And then next we run it on the right end of the Ponte polygon, and it matches the word Vedra. And then next we redo the calculation, and we run the Solr spatial search again. And from the right end of the polygon, it matches beach. At this point, there's 0 remaining terms left. That means we have a match. Finally, to deliver the result as a single image to the user in Masonry view, we merge the four polygons and creating a 1 single bounding rectangle using a triple IF image request. The dilemma we have in multi-word search is we want to have return control back to the user as soon as possible. So the search is done on the fly, but that means the complete result set is not available until all the search on all maps are completed. Therefore, the result count is not immediately available. And next, Trey is gonna talk a bit about the other challenges we run into.
So when we're dealing with this large volume of data and what it takes to be able to deliver this on a responsive front end, that's where we got to start getting into a little bit more difficult zones. I mean, one of the things David had brought up is this index, because of just gathering all the coordinates on the maps, it gets up to 167 gigabyte Solr index, right? Solr index or the
Yeah, this is the annotation index.
Yeah, Solr, the index just gets massive, and then we have to be able to search that. So one of the things that happens is when we're actually returning a result on a search or a multi-word search, we try to cache as much as we can. So if that gets repeated or you return to that search, that will be more responsive to the user. And also we're not applying processing power again to try to do that same thing repeatedly. So we're always trying to give a better response to the client. So one of the things we're looking at in this next iteration, right now we're on a scale of, let's see how many people in this room can work on it, versus how many people in the 7,000 to 10,000 people in a day can be working with this without having any response issues. So the next kind of problems we're trying to look at trying to make sure they're reasonable as far as the response time. One thing we've also hit, and David, maybe you can talk about this one, is there's a limitation right now that we're hitting because of anybody making changes. What happens and how does those changes get integrated? So maybe you can speak about that.
Yeah, when you make a change, the change is immediately available, but they won't be searchable until up to 24 hours later, because we want to limit the number of time, the amount of time, limit the number of times each time we commit changes, because whenever you commit, it invalidates all the caches, and which takes 20 minutes to warm up. So yeah, and then in the future we plan to, have planned is to separate out the Solr server, to have one Solr server dedicated to for indexing and one or more dedicated for searching. And we are also planning to do more upgrades to Solr, and also implementing Solr Cloud, and yeah, for distributed indexing and search.
Right, so that's the kind of the next steps. In order to get it live on David's site and actually make it happen, we have to make this robust. And so we can see the results, we can get to the content, but what's next? How do you deliver that? Is there anything?